Can you upload an example of good lab? Because I also don't know how to do them, and it would be good if we had some example.
Okay, so I will try to mark and get one of the best lab books, and I will upload it as the example of a good one. But in general, again, so we have different sections. Okay, so we have title, we have aims. Usually aims come with the hypothesis, but not all laboratories, not all experiments, they will have a firm hypothesis. So usually aims are fine to show in your lab book. So what else? You have materials and methods. Then you have results, discussion, and conclusions. So again, title is to make sure that you find it easily after you kind of performed it few days before you try to find it. Okay, so the title actually shows what is inside, and you should work on title first of all, just because some people say like testing, let's say, proteins. Okay, it is a very broad title. This broad title does not tell you anything. So if you scan through your lab book later in future, you will not understand what this experiment is about. Okay, and if you don't understand what it is about, then you will not pay attention to what's inside. So the best title would tell the reader that, of course, it is about dialysis. So let's call dialysis. And then you kind of explain what you were looking at. So Benedict's solution, some Bradford's test, etc., etc. Sorry. You need to explain what is inside. And this is a very good place, title, to give a small explanation for future you to understand what is going on.
Okay.
So you could copy the title from the manual, but I will tell you that not all manuals are very good at titling. So some of them, they just give a very broad naming, and this naming is actually not very kind of applicable to your particular experiment. Okay, you could do that, but if you find a better solution or better naming for your experiment, just use it. Again, the title is for future you. Aims give you the main reasons why you actually perform the experiment. So the aim for our dialysis or osmosis, so for osmosis, let's talk about osmosis. So determine how glucose or sucrose is behaving during the osmosis, etc. How we have the change of masses. So this is 1, this is 2, masses according to timing, etc. And finally, how you would expect behaving of the cell in the same condition, cell behavior. Well, of course, we didn't do that, but in terms of your lab book, you will have the very distinct aims. You might have 10 aims for this particular experiment. You might have only 1 aim, but the main thing here, don't try to squeeze all the aims into one, because it will create some misunderstanding in the future. Okay, so if you have 5 aims, write them down all. If you have only 1 aim, just keep it. Again, don't try to squeeze everything into one single aim. Again, about materials and methods, I received one email from I guess it was MB1 student. So materials and methods. Again, materials, they show what you use for this particular experiment. So why you will want to show it? Because sometimes in your protocol that you receive from your supervisor, it tells you to use isopropanol. Propanol. And you don't have it. So you decided to test ethanol instead of isopropanol. Of course, if you don't reflect it in your materials, you will never recall that you were using ethanol instead of isopropanol. That is why materials are very important. You use something, and this something might be different to the protocol that you actually use. So because they might be different, you need to reflect it. Otherwise, you will not recall these in 1 month or something like that. Actually, the next day, you most probably will forget it. So write it down. Materials are very important. And now the methods themselves. So, okay, the protocol that you took from your supervisor uses isopropanol. And it uses it at 0 Celsius degrees. Now you only have, let's say, minus 20 Celsius degree beaker, and you use it at minus 20. So you change your protocol and you write it down. So you write it down that, so ethanol is at minus 20, while your isopropanol was at 0 Celsius degrees. Of course, it is the change of the protocol. You have to write it down. You will not recall it in a few days. Of course, if you have made a discovery and you just cannot repeat it, then it's not discovery, okay? Also, if you made a mistake and you cannot troubleshoot it, you will stay with the mistake for a long, long time. But if you wrote it down and now you know that mistake happened because you were using ethanol, of course, this is a very good to troubleshoot your experiment. So the results only include results. So you obtained 10 milligrams per milliliter of your DNA. You write it down. You run the gel, and on gel you see 3 bands. Okay, so instead of 1 good band, you see 3 bands. You write it down. You don't discuss it yet. You just write everything down, and then in the next section, which is the discussion, in the discussion, you are giving your thoughts. Okay, so your thoughts about everything. Something went wrong. You give your thoughts about it, why it might have happened, what you should look at, what you actually want to tweak in your protocol to get to the results that you want to obtain, etc. All your thoughts are given in the discussions, not in the results. In the results, it is a pure fact that you obtained this, this, and this. That's it. If you did not obtain anything, you just write, okay, so the experiment is crude. I did not obtain any cells. I did not obtain any DNA, etc. Now you need to troubleshoot it. Why you did not obtain anything, but why you did not obtain anything is given in the discussion. Okay, so my medium was 10 Celsius degrees, and it actually killed my cells. I think that it is a problem. Next time I will repeat it, but I will need to heat up my medium to 37 Celsius degrees. This is troubleshooting your thoughts, and they go to discussion. Okay, so in your conclusion, you say, this experiment was not okay because I messed up with the medium. For the next time, I want to look at aim number 3 because it did not work. Aim 3 did not work. Now we need to look at it on a more precise way, or anyway. Or in case you obtained very good results, you write something like, during this experiment, we find this and this and this. Okay, so findings. This is your conclusion. So you kind of finalize the whole work. And you finalize it by reflecting your aims, because aim is actually the opening of your whole work. So you finalize it and say, okay, so we have findings, we have troubles, we troubleshoot them, we try to make sure that we don't repeat them. So as the final conclusion, we repeat experiment, having tweaks to our protocol at step 1, 2, and 8. 8 like this. So you have these tweaks, you reflect them from the discussion, because here in discussion you already explained why 1, 2, and 8 are not fine. Okay, so but in the conclusion you actually kind of reference these thoughts so that you don't need to go through the discussion. I mean, you don't need to read it again and again to understand what was there. So the conclusion is as important as any other section. Okay, so I have a question about the hypothesis. So again, if you have the experiment with the hypothesis, you have to write it down. If you have the experiment that supports the hypothesis of the previous experiments, you don't need to write it down again and again. Just reference it, like in aims, you write first aim to redo the experiment number 6. Of course, it tells you that you are redoing the hypothesis, the aims, etc., etc. So the setup is the same, everything is the same, but the only thing that you change is actually the temperature of your medium. And because you now change the temperature, you are redoing the experiment, but you don't need to write this hypothesis again. So again, everything depends on the type of experiment you do. If you are continuing something, kind of have the continuation of testing of your hypothesis, you don't need to write it down. You just have to reference it somehow that you are continuing it, okay? But if this experiment is the start when you have to show these hypotheses, of course you have to show it, usually in aims and hypothesis section, okay? Just a second, guys, I have a call. Okay, so I hope the question about hypothesis is clear. Now the question about okay, so for your work, I mean for your laboratories that you do during this course, we give you the manual, and if you watch the videos and you see some tweaks of the manual, you probably should show it, okay? So sometimes instead of adding, let's say, 1 molar, we might have added 1.5 molar concentrated solution. You have to show it, okay? Don't trust the manual as it is, check it. Okay, so when you watch the video, just don't watch it blindly. Take your manuals close to you, and if you see some difference between the manual that we give and the video, reflect it. This is it, okay? If there is no difference between the manual and the video, then of course it is fine to copy materials and methods from